During this lesson, we will be talking about quadratic functions. And a quadratic function is pretty much any function that contains an x squared. And the parent equation, or the original equation for a quadratic function, is y equals x squared. This is essentially the simplest and most basic quadratic function, and it's the base of all the other more complex quadratic functions we'll be doing during this lesson. So in order to graph this parent equation, to get the parent graph, we need to create an xy table. So let's create an xy table with inputs from -2 to 2. So -2, -1, 0, 1, and 2. And so let's plug each of these numbers into our equation. If we take -2 and square it, we'll get +4, since two negatives make a positive. So let's write +4. If we take -1 and square it, we'll get 1, since two positives make a negative. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So as you'll notice, you'll see that we have some repetition in our outputs for different inputs. And this is because since quadratic functions contain an x squared, it means that for every input, for every same output, there will always be two different inputs for it. And so now that we have these coordinates, we'll be able to graph our equation. So here's a simple graph that we can begin graphing our equation on. So in order to graph this equation, we would simply look at our coordinates. So for the first one, since our coordinate is x equals -2 and y equals +4, we would go to the left 2 on the x-axis and go up 4 on the y-axis. And I'd make a point here. And for the next one, -1, +1, I would go to the left 1 and go up 1. Make a point there. 0, 0, I would simply make a point at the origin. For 1, +1, I would go to the right 1 on the x and up 1 on the y. And finally, for x2, y4, I'd go to the right 2 on the x-axis and up 4 on the y-axis. And now that I have all these points, I can connect them together in a curved line. And as you can see, this graph forms a V-like shape, and this shape is called this type of graph is called a parabola. And this is essentially the simplest type of a quadratic function, like I said. So this would be considered the parent graph, since it was formed by the parent equation. However, most parabolas aren't this simple, and they are usually variations of this particular parabola. And these shifts or these variations are done using another type of, or they can easily be graphed using another type of equation called the vertex form equation. And this equation reads y equals a times x minus h in parentheses squared plus k. So in this equation, y and x are once again our x and y values, and these are variables, which means they constantly change. And a, h, and k are constants, which means that they stay the same throughout when using the same equation. So in addition to just being constant, they also have particular roles they play in the equation that make them very easy they make it very easy to graph the equation. So K essentially, or I guess I'll start at the beginning. A is responsible for stretching and compressing the graph. So essentially, the bigger the number A is, the skinnier the graph will be. So if I had a graph with an A value of 2, that means its graph would be skinnier. If I had an A value of, say, 1/2, that means it'd be fatter. And also, if I have a negative A value, such as -2, that means that in addition to being skinny, it would also be pointed down. So A is essentially responsible for doing the shifts like that. H, on the other hand, is responsible for shifting the graph on the x-axis, so it shifts it from left to right. So if I had an H of, say, +2, that means that it would be shifted to the right 2, and if I had an h of -2, so if I had an h of -2, then we go to the left 2. And finally, k is responsible for shifting the parabola up or down. So if I had a k of +1, I'd have to move my graph up 1 before starting it. So now that we know this fact about how to graph more complex parabolas, now we don't really have to use an XY table, and we can just get straight to graphing it from looking at the equation. So let's use this new techniques that we've learned on a sample equation. So the equation we'll be using is y equals 2 times x minus 1 squared plus 2. So let's start off by looking at our k and seeing that we have to how far we have to move up in the y-axis. So in the y-axis we have to move up 2. So let's start out moving up 2. And now let's look at our h shift. So for our h shift, our h is equal to 1 since it's -1. This means that we have to move to the right 1. So that means that our first point, or our vertex, will be right here at -1, 2. I mean at +1, 2, excuse me. So now that we have this point, it's pretty easy to find the other points. So if we look at our a, we see that since it's greater than 1, it's 2. This means that our graph is going to be stretched out. So, and since you only really need 3 points to graph a perfect parabola, an easy way that you can get the other 2 points when you're dealing with a whole numbered, when your a is a whole number, is to just go up 2 and over 1 on each side to get the first, to essentially just get the first 2 points. And this only works for the first 2 points because since quadratic functions don't increase in the exact same numbers, they increase by more and more as it goes on. This can only work for the first 2 points. But it's very easy if you just want to get 3 quick points. You can graph your equation very quickly. So now let's take a look at this. So when we connect the lines, we should get a completed parabola. So now that we've graphed this equation without using an XY table, let's go back and make one just to make sure that we did it correctly. So let's once again plug in -2, -1, 0, 1, and 2. And it's a little bit tricky to plug these x values back in because we have to consider order of operations. But using order of operations, let's start with -2. So if we replace x with -2 in the equation, we'll start with the things in parentheses. So -2 minus 1 is -3. And after parentheses, we do exponents. So -3 squared is 9. And then 2 times 9 is 18. Plus 2 is 20. So if we included -2 on the graph, y would be 20. If we're doing -1, it would be -1 minus 1 would be -2. Squared would be 4. 2 times 4 is 8, and 8 plus 2 is 10. So this would be 10 right here. And if we're doing 0, 0 minus 1 is -1. -1 squared is 1. And 2 times 1 is 2, and 2 plus 2 is 4. For 1, 1 minus 1 is 0. 0 squared is 0. 2 times 0 is 0. So really 0 plus 2 is just 2. And then finally for 2, 2 minus 1 is 1. 1 squared is 1. And 2 times 1 is 2. And 2 plus 2 is 4. So since we only included 3 of the points, let's just look at the points that we include on our graph. So the first one we included was 0, 4. And this point can be seen right here. It's our y-intercept. So that proves we have that point on our graph. Let's look at our next one, 1, 2. This can be seen right here. This is actually our vertex, like I mentioned earlier. It's the point where our graph starts. The next one is 2, 4, which we also have in our graph. 2, 4. So by looking at this, we can tell that we did in fact graph this. We graphed this equation correctly. And once you understand A, H, and K and vertex form and how to read it and how to understand it, it becomes very easy to graph more complex equations without having to go through all the time of making an XY table every time you need to do it. So that essentially concludes today's lesson. Thank you for watching.